Okay, good morning, everybody, and welcome to KETIV Virtual Academy. We're so excited that you're here. If you're joining us on YouTube, please be sure to hit that subscribe button or check out the link in our description to join us here on Zoom. And if you're here on Zoom, welcome or welcome back. Today we have Javier Chavez joining us, and this is part 3 of our 2D to 3D transition series. We got some feedback that we wanted to see this done from start to finish and a little bit more technical, so we took that feedback, and Jav's here today to present. I also wanted to send you guys a link to check out our upcoming sessions. In the first week of every month, you'll receive a newsletter that lets you know the sessions that are going to be taking place this month. But you can also check them out on our website and get future sessions too. So please be sure to check out that link. And if you have any feedback about the session, please fill out the survey at the end. That's from Zoom, but it'll show up in your browser, whatever browser you're using. It'll show up right after the session, or you can send us an email at marketing@ketiv.com. Let us know what you thought and if you have any feedback. And I will let Jav take it away.
Awesome. Hey, thanks for the introduction. And I'll go ahead and tell you a little bit about myself. We're going to be taking a look at workflows, but before we do that, of course, I just want to tell you a little bit about myself. It's been a little while since I think I've done a KVA. So as you can tell, I've been here a little while, and my experiences at KETIV has been mostly through consultation, right? Delivering training, delivering services around a lot of these products. But prior to that, I used a lot of these tools, competing tools, and I spent quite a bit of the time in the RV industry. So think of travel trailers, motorhomes, etc. That's where I spent the majority of my experience, and I got a lot of good things out of it in terms of dealing with other things outside of engineering. So ERP systems, other processes, working with vendors. So you'll notice too my expertise in AutoCAD and Inventor and Vault. And I think the part I have more of a passion for around is really the data management part of it, the product lifecycle management part of it. So hopefully that comes through. And we'll go ahead and continue here. Let me close another window here. There you go. So this is part of a series, and today's focus is getting a workflow down, right? And so part of it will be conceptual discussion, but another part will be the technical. So we'll highlight that in just a moment, but we're going to highlight that bottom right corner in terms of talking about the workflows, making sure we recognize the things that it takes to develop these workflows from a technical aspect and also from a organizational aspect, right? And we're going to focus a little bit more on the tools, I think, than we normally do, but we're certainly going to talk about people and the processes, right? And so you can see the agenda. We'll tackle these in this order. And again, the technical aspect, we're going to focus on a little bit more heavy, specifically around this, right? Reusing data so that, when you do make that transition from 2D to 3D, you have something to start with, something to work with right away. And you could kind of launch yourselves a little bit more quickly, as opposed to starting everything from scratch. And in some cases, you might need to, right? But we're going to try to recognize when you don't, right? And you're going to generate lots of information. How are you going to manage that? So we'll talk a little bit about data management and how important that is. But a big focus is going to be on that, on the reusing of data. So with that said, let's talk about the process part of it. If you don't know what your current process is, you're going to want to document it. Right. So you want to understand it. And even if you think you're going to want to do this so that you can identify the real participants, the real outcomes and dependencies. Because if you do this with other people within your organization, you're going to find out what you thought worked a certain way, right, actually works different. Right. So you're going to want to answer some of these questions, right? What data do I need in order to, get to this step? Who's responsible for that data? Are there numerous, ways you receive that data or streams? So look at all those things and actually create a real chart so that you can go back to it, modify it, especially if you want to make a change. In fact, if you're going from 2D to 3D, this might change, right? You might recognize that your current process is going to change, and there might be more arrows or more boxes within your workflow. So take a minute to document it and work with other people to do so, right? In that process, you're going to want to recognize, the data that you receive in order to generate your engineering information, right? How much of that transfers over? And, I can think of some things like, descriptions and part numbers, job numbers that you might actually go from a sales order in an upstream process to your drawings, or at least to metadata. So think about those things, and then think about the data going out, right? Who needs it? Does the manufacturing floor need it? Right? Do you need to export other types of data like DXF or step files for machining? Right? Is there a different type of data for different audience? So think of vendors, right? Think about those inputs and outputs. Put them on that same workflow document. In notes, it's going to help you in this process, right? So again, taking a look at dependencies. And figure out, like, when something happens, are you manually triggering other things to happen? So think of, when you release data, is somebody having to manually gather prints, PDFs, DXF files, at a certain trigger point or point in the process? If so, look for things that could be automated that way. And when you put in the right tools and you consider the right tools, there's always the possibility to automate these things, right? And so you'll want to ask yourself, how does this data get consumed? Is it electronically? Is it, simply putting it in a folder? And again, can we just send the raw CAD data, or do we have to translate it to a different format, or a different a way where they can be used? So the other thing before we get to our workflows is people, right? Identify the people, attach those people to different responsibilities within your workflow, and definitely recognize that some people have different skill sets. If you're going from 2D to 3D, you're going to want to see who has an aptitude for learning some of these tools that can help lead the charge, or at least even the load while you're making this transition. And through that process of identifying these people, you're going to find champions, people that are going to help you and make suggestions that are going to maybe make this transition easier, right? You don't want to live in a silo, so you're going to want to make sure that you validate some of the decisions, the workflow you're creating with others. So the last thing I'll say about this is, you're also going to want to deal with people that don't do CAD, that don't really care if it's 3D or 2D. But they administer the data. So I'm thinking of dock control. Dock control will typically, take information engineering data and check for standards and then release it to people, right? Or give it back. So how do they fit into the process? And can their input, streamline the way you're going to plan for this? So again, conceptual here, but if you document it, and we do this for assessments, workflow assessments all the time. And it comes in real handy because it identifies the things that need to change from your current, and hopefully, you can go into the future with a new process that's a little bit more streamlined. Okay, so in terms of tools and workflows, we'll address starting from scratch, right? And what I mean by that is basically, if you're starting this journey from 2D to 3D, one of the first things you're going to have to do is generate CAD data. And even before that, you're going to want to select the proper tool, right? It could be Inventor, and we're gravitating towards that here on this session, but it could be Fusion if you're doing something more conceptual. It could be Plant 3D if you're actually going from 2D and developing things like large piping schematics, or processing plants, right? They're a much larger scale, and Plant 3D could be a better fit for that. And of course, if you're dealing with something architectural, your transition from 2D could mean you're using Revit, right? In some cases or instances, they might be a combination of some of these tools, and you're probably never going to throw your 2D away. You'll still include AutoCAD somewhere in there. There's some things that don't transfer well to 3D, or are easier kept in 2D, like schematics sometimes. So with that said, right, you're going to want to become proficient with the tool that you choose, and you're going to want to consider training options, right? So you could certainly, do a DIY route and look for training on your own. One thing I would recommend is, checking out our KVA videos. And in addition, I'll also talk a little bit about some unlisted videos that we're going to make available to people on this session. So you can look for links, and I think you'll see them in the chat somewhere. But links to Jumpstart, these are unlisted videos. You can't, search and find them on YouTube, but they are on YouTube. And of course, if you need standard training or custom training, right, consider us, right? We've got quite a bit of experience helping customers make that transition in different industries. And, if you do end up going to our KVA channel, by all means, don't search up at the top. Try searching the channel on the right-hand side and searching for something specific. That'll filter out to our KVA videos, and I think get you better results in doing so. Okay, so again, starting from scratch, you're going to want to plan for this and identify how much or how little you're going to actually develop from scratch, right? And in the next slide, I think trying to figure out how much you can reuse will tell you how much you're going to have to develop from scratch. And I'm talking about new parts, new assemblies, new ways to document things, right? So let's talk about how you can reuse some of your existing data, specifically 2D, right? And when to reuse it. So if you have existing 2D data, it's still useful. You can leverage it for your 3D data, and you can literally copy and paste sometimes some of this data into 3D and start, making that transition. You're going to want to be careful, though. You're going to want to make sure that you identify the right parts or right components to bring in and right designs. Usually it's going to be something that's static, right? That doesn't change very much. That's super helpful. There are some, caveats to bringing this data in. It's going to be, maybe simpler data as opposed to more complex. In some cases, it's going to be static data that sits in a library ready to use to assemble a much larger assembly. And so your final assemblies, your final designs might be a combination of library components being brought in, and then a few, fabricated custom components that build your overall design. In fact, some of you contract manufacture. That means you don't design anything. You bring in part number one, part number two, you purchase those things, and you assemble it in a unique configuration, and your engineering services, your design services are really what you're selling. Okay, so not a good fit for really complex designs in a lot of cases, and especially designs that are prone to change. So you'll find that, if you do bring this stuff in, you may not have designed it the way you normally would in 3D, and it won't lend itself to changing things, especially with automation. You might not put in the right parameters to quickly update for automation. So if you are considering, automating this process at some point, just keep in mind the static parts that don't change, possible to use in automation. But if parts are going to change, length, width, height, any type of parameters are going to constantly change, you're going to want to probably design that from scratch and design it with the sole purpose of automation. Okay, so with that said, let's look at this example of how you can do this. I'll walk you through this video, and we're basically going to look at a assembly that's already been transferred from 2D to 3D, and specifically how maybe we got this static component that we either purchase or it doesn't change very much, and we're going to go back in time and look at an AutoCAD file and bring it in. So first thing we're going to start with is just creating a brand new part. Right. So again, we're simulating the process to create that part and bring it in from 2D. And we're going to start with a brand new sketch, just like we normally do. Maybe your standards say, hey, the front face is always on this front XY plane. So we'll still do the same thing you normally do with 3D modeling, right? Assuming you've gone through some basic training. And there's tools that we can leverage here, an import tool specifically to bring in AutoCAD data. So when you open this up, you'll get a wizard that's basically focused on, bringing in AutoCAD stuff. It recognizes layers. You can turn them on and off, and you want to make sure that you only bring in what's necessary. So you're going to turn off layers you don't want, and also select the objects that you do want. So we're going to basically say we don't want everything, not that top right view. Instead, we're going to window round just the top and the front view. When we click next, we just need to verify that it's reading the right units, millimeters, and we always want to constrain endpoints, right? You might apply the other geometric constraints, but I would advise not to, just because it may not do it correctly, not the way you would do it. So from here, we can move the data, right, and put it closer to 0, our geometric center for the part, and you'll see it's not fully constrained, and you could take a lot of time here to do that. And speaking of constraints, the dimensions came in as dimensional constraints. So we could actually click on them, and they're parametric. And you saw that whole change just a moment ago. Okay, so to fully constrain this, right, because that's a good practice, we're going to take another way. We're going to take another method, use another method to do that. So instead, what we're going to do is we're going to use these block tools that are available and create a block out of this geometry, right? We're going to name it. It's very similar to AutoCAD blocks, and we're going to select that front view. And when we click OK, that is fully defined. You cannot change the diameter of that. You cannot, take away the tangency points. But we do need to lock it down in space. So we'll add just a few constraints to lock it down in space. So this is now quicker, right? Because we don't have to constrain every single little thing. We're taking it and not changing it. Okay, so the top view, we're going to keep around for one specific reason. We didn't extrude it, or we're not going to extrude it. We're just going to extrude that front view. And when we decide how deep to extrude it, we can reference that other dimension. So that's just a little piece of knowledge there you can take with you. If you do take other information, you can reference it. You can pick it from outside of that process. So now what's left is adding in more information, like part numbers and things maybe into the properties. So that's a really basic example of how to get that part into an assembly and start reusing it right away without having to start from scratch, right? Copy, paste, extrude, and perform some modeling functions. So it's really a combination of the CAD data mixed with the 3D data. So in a more advanced example, like this one's kind of taking the process to the limits, I'd say. So let's take a look at it. We're going to focus in on the bucket here in just a moment, but you can see a lot of these components were derived from 3D or 2D rather. And you could actually create separate parts, only include the sketches, and do kinematic studies. So we're going to focus on this bucket component and just give you an idea as to how this might work, and use several sketches. So there's already one sketch there that was copied and pasted from AutoCAD. We're creating a brand new sketch. We're opening up AutoCAD directly from Inventor. And when you do that, you can just copy and paste directly. So as we paste it in onto this other plane, it's going to be in the wrong position or wrong place. And we're going to go ahead and just move it so that, in relationship to each other, there's a common datum point or common point that they both share. Okay, so we have a side view, we have a bottom view or top view, however you want to look at it. We're just going to use regular extrude tools and reference the 2D data, whether it's on one plane or the other. We can pick the dimensions to create geometry. So if we expose the sketch, we can reuse it again and start creating all the other geometry. The gussets, there's a number of gussets that are going to get created here. We could also create other types of geometry, like work planes, and still reference the points in the sketch or the dimensions on the sketch to locate them. And once you do, reference them, that's how you control them, right? So we're going to extrude from plane to plane to create, more gussets here. And you'll notice that they're fairly chunky and big. We'll refine those as we go. But in each of these new pieces of geometry, we're creating new bodies, and we're working in a part environment. So it's important to note that, hey, this is one part, even though technically it could be an assembly. And if it's static, right, this is the best way to handle it. There is a process or way to, bring this to an assembly level and explode it as you create different bodies. But for right now, we're just going to bring in one last sketch, and we're opening up AutoCAD again, pasting into another plane where we created a sketch plane. Okay, so the details on how to do this, we've got tons of videos, and that's what we're gonna, send you links for. But again, we're extruding maybe another side plane here to create more plate geometry on the side, and of course the bucket teeth are going to get extruded there, and reference a dimension from that side sketch. So in the end, what's left is creating more bodies to represent each and every individual component. So in a single part, you could turn these on and off, and like I said, there's a workflow where you can explode this and turn each body, right, each one of these extrusions into its own individual part and an assembly that contains them all. Okay, so now what's left again is adding, the information that you normally don't have in 2D: colors, decals, part numbers, even, material properties. Is this made out of steel? So, once you have this, you can see we've got to this fairly quickly. The unedited video of somebody doing this took about 12 minutes. So it doesn't take that long to copy this data into sketches, into an environment where it can be reused right away. Okay, so let's go ahead and move on here and talk about how and when you might reuse 3D, right? So if you're using 2D, great. You just started building up a library of components that you can reuse for your designs. But what about reusing existing 3D? You don't have any, right? So we'll talk about that in just a moment. Where do you get it? But let's talk about when. Again, similar criteria, preferably static parts or components that don't change or move. And in a lot of cases, they're purchase components. Okay. And again, you may be building a library of your own of these things that you typically purchase and don't change. You just consume them. And there's a lot of websites out there where you can download these directly. So again, not a good fit for things that maybe change. If they can be swapped out, that's one thing. But if you're taking and downloading a part or an assembly and you want to stretch it, that's typically not yours, right? Or maybe it doesn't have information that that lends itself towards it. And of course, automation as well. So be careful with that. If you're going to automate some of this, take a careful look as to, is it going to stay static within the automation, or are you planning to stretch it, change it in a number of ways? Okay, so let's now take a look at, sources for this data, right? So a lot of these tools come with existing libraries of information. Plant 3D does, right? Revit does, and Inventor's no different. Inventor has three-quarters of a million plus standard parts that you don't have to build. So the nuts and bolts, they're there. The pipes, they're there. And even if you just need a variation on that pipe, it's customizable so that you can create a different version of the pipe that's there. They might only have stainless steel pipe and black pipe, and you might want to create galvanized pipe, right? You can customize the existing pipe that's there so that it reflects the right material, the right part numbers. And again, we have tons of videos on that subject. You don't have to create it. It's already ready to go with parameters and stuff to help you edit those, right? And it fits into the automation scheme. It can use some content center information. We know how that works. If you're going to get data from vendors or suppliers, you're going to have to import that data from somewhere. If you're fortunate enough that they have, the same tool, they could just bring it in, right? But in a lot of cases, you're going to have to work with neutral formats, right? Exchange formats like STEP or IGES, or, you can see some of the lists there. STEP is preferable. It's probably one of the more common ones. And, for some reason, your customer has a different tool, they can send you their native format, their native SolidWorks files, Creo, et cetera. In a lot of cases, Inventor can work with that directly. And the one caveat that you're going to want to think of is they gave you those files. It's their part, their design, and they're focused on the details, right? The details of a breaker, the details of a motor that they manufacture and sell to you. And they have a lot of internal components, a lot of little nuances. That is 100% their focus. For you, this might be just a tiny thing that makes your overall design, and it may contain too much detail. In fact, last week we spoke to a customer and they sent me their design, and it was 1.2 gigs. It was gigantic, and it shouldn't have been that big. It was complex, but it shouldn't have been that big. And it's because they purchase a generator from a different vendor, and they get every nut and bolt, every internal component with it, and they haven't really uh, changed it so that it's lighter and just meets their usage needs. They just need to know a part number and an envelope, right? How much space does it take up? Maybe how much it weighs, right? So that's the next part of this. How do I get the data, bring it in, and then make sure it's, we create it, or, we process it in such a way that it's usable, not just now, but in the future. If you use these things all over the place all the time, and you're going to do that for the next, 3 years as this generator's available or there's motors available, what do I need to do to make it better? Okay. So with that said, let's see what that process looks like. I'm going to go ahead and kick off the process here. It is import, right? That's the easy button, just get it in. But then you're going to want to simplify it. It's going to take a little bit of work. There's tools purpose built for that. And then when you're done, I'm going to show you something that'll help you simplify it even more and achieve, just a much more lighter weight version of the part. You can see an example of this motor. In the example that I'm going to show you, and we're going to be flying through this, we got a 95% file reduction, right? We took out internal little details. We went from 42 megabytes to 214 kilobytes in the end, right? To see a major improvement in performance. And that's just not in this current design, but in the future, if anybody uses it from our library, they'll see the same thing. So don't shoot yourself in the foot. Make sure you process these files so that they're lightweight and usable in the future. So let's go ahead and begin here. And again, we're taking a look at this same model, and we're going to flip it over and take a look at what's underneath it, right? And you'll see right away there is a motor that gets used all over the place. There's 3 or 4 of the same motor. And if we take a look at it and focus in on some of the details here, you'll see there's a lot of details. There's internal stuff that you can't even see that we don't need. So keep that in mind as you do this. If we focus in on the size, initially, right, if we go through the process of importing this over again from the vendor, you'll see this thing is like 20 something megs, right, in size. We don't know if it's going to explode into an assembly or if it's a single part. For us, it's one single part in our system. We want to treat it as such. We don't need the complexity of an assembly. So you'll see some things there, right? The goal is to get this as one purchase part, make it as lightweight as possible, and still know how we connect to it, where shafts go in, where wiring goes in, and how much space it takes up. That's what we need it for. So as we bring it in and open it up, it goes through a conversion process. You have the choice of linking it or converting it. We want to convert it so that we can have some choices. And you could get a preview. And in the preview, as you go through this preview process, you could decide and just see, well, what things are a part of this file. It looks like it's an assembly, and I see motor casings there. I see some internal components and things that we already know we don't want. That internal thing that you see there, I don't know what that is. It says winding, but we're never going to see it. So you could turn it off here. I'm going to leave it in so that I can show you more ways as we import it into our environment that we can simplify it. So we brought it in. It's now an Inventor assembly with parts and components. It brought every single component in, and we just saved it. So let's take a look and see how big it is now, right? And there's a little trick for an assembly. If you want to see truly what the size is, you run a pack and go on it. And you can see it's 40 something megs. It blew up from 20 something megs to 40 something. Already it's getting bigger than we want it. That is too big for a little tiny component of our assembly. So with that said, let's continue and see what we can do to simplify this. We're going to use a series of tools, and within the assembly environment, you could start editing what you really want to maintain in this assembly. And so that internal component, when I launch it, I could pick that edit view tool to say, do I want to include it? Do I want to exclude it? I could change my view to see what's excluded, and that's what we're going to take out. And simply by clicking OK to that, right? On the left-hand side, you can see the winding is now turned off. So step one in simplification, get rid of stuff you don't need. The next step is defining envelopes. So we're creating a representation of the casing there, that gray casing, and you have two choices: a box. I don't want to represent it with a box. What's closer is a cylinder. So the option to convert that to a cylinder at some point, right? It's available. So you're going to see here, okay, that's better. You have tools to size that and snap it to the original casing so that it's the exact same diameter. And you could size it accordingly. So great, now I have a cylinder, and I could either get rid of the casing now or maintain it. I'm going to choose to keep it around. The cylinder is not a perfect representation. It's close, but it's not perfect. So I'm going to keep the casing around so that we could refine it later. And you can see the casing underneath there. It's got flat sides, and we're going to refine that just a little bit later. For now, we're going to continue defining an envelope representation of the components. And if you don't see those tools, you can go to the panel and bring out those simplification tools at any time. So it might not be there by default. And if I click on there, right, we're going to go ahead and start maybe defining the envelope for that black plug, right? It's going to be a series of rectangles or boxes to represent the different sizes of boxes that I see. And we don't need a lot of detail for that particular plug, but we're going to need some more detail for the white one, the male plug. So this is going to be very, very simplified. But again, it's going to capture the things that we want. So similar process. And in the end, when you're done creating 2 or 3 boxes on top of each other, you can replace that black plug with that boxed version of it there. It's much more lightweight, and it doesn't have a lot of detail. So at this point, I think we're ready to maybe continue with the process and create one single simplified part, right? There's other parts that have maybe too much detail. We're going to wait and maybe simplify this differently. Instead of these real simple boxes or rectangles, we're going to refine these a little bit differently once we get into part mode, right? And so creating a simplified part basically takes all this and creates a separate part representation, and you have a choice of ways you can create that. We're going to create multiple bodies, use a metric template in accordance with that, give it a name, and what we have now is one single part, okay, with multiple bodies. So the bodies now show up, and it brought in everything except for the winding. It also brought in extrusions for those boxes that we created that are going to represent plugs, etc. And so we're going to isolate the casing now, okay, as a body, and we don't want to see the other stuff. And I do want to bring in maybe the box that represents, or the cylinder that represents, that's going to represent the casing. And you can see there's an overlap there. And what we're going to do is we're just going to sketch on top of the solid and use just regular CAD modeling tools to cut away the information. And we can project the geometry from the casing so that we know where that cut is exactly, and continue to use just common sketching tools. So now we're really combining the 3D model with some modeling. But again, it should be less work in terms of measuring that, so that again, we can use common extrusions and cuts to get to what we want. Okay. So, we're going to simplify this and create another solid. And once we have a good representation, we can go back and edit our import of this data, right? And edit the derived assembly. We could turn off the motor casing. It's no longer a part or component of this. It's linked back to the original assembly, but this is now our casing, and ours is better than what we had a minute ago. Okay, so we'll move on to the next part. It'll be a series of, similar processes. I just, for the most part, I want to show you just more tools that are available in part mode. So in a moment, we'll go ahead and isolate the male plug. And we want to maintain a lot of the detail here. So when you're in a part environment, if you don't see the simplification tools, again, you could go to the panel and bring these out. And there's tools there just to remove, edges, rounded off edges, and make this more squared off and simplify this. In addition, there's also tools to start eliminating voids. So there is a void inside of this with all kinds of detail. We don't need it. We're going to plug this up and sort of fill it up, if you will, as if there's nothing inside, just by plugging up the holes. And when you do that, man, we've got the most basic representation of this, and we still know where the wires go, right, on this. And so if we start to bring things back, the only thing that's left are these red components, and we'll streamline the process for this, but that's the only thing left that we need to simplify. The two components are exactly the same, just mirror images. So we're going to focus in on one and really go through the same process of using simplification tools, sketching tools, and just common modeling tools, right? And we are borrowing from the original, so we're borrowing edges, disassociating them eventually because that red part will go away, and we'll replace it with our own extruded version of the same thing. Okay, so again, you can see us going through that extrusion process, and in the end, what you're going to see is, radiused edges going away, and us getting or ending up with a simplified representation of this. Okay, so when we get to this, right, to this point, we're going to go ahead and save it, and I think you'll see that when you look at the file size, it went down to 630 or something like that. But as one last extra step, right, a little trick, you save it as a SAT file. Okay, you import it back in, and when you import it, it's going to come even smaller. All the information on the left-hand side in the original model is going to be taken away. And as you bring this in, right, you'll have the same visual representation of this, the same boundary conditions, etc. But when we look at this newly imported version of this file, it's only 214 kilobytes, so much smaller. And then when you compare it to the original, right, there's not much difference in terms of the space or volume it takes up. Okay, so there's a lot of little tools that we quickly exposed you to. Again, if you want to see where these tools are or focus in just on that process itself of just simplifying, there's lots of information out there. You can certainly talk to us, and we're sharing some of the links as well. So, and I apologize, it's starting over again, but let's go ahead and move forward here. Right, the last thing we'll talk about is how you're going to manage all this data. So what used to be 2 or 3 drawings is now going to be 50 parts and assemblies and drawings, right? It's going to be 10,000 part assemblies, etc. You want to account for every nut and bolt on a bill of materials. Typically, you'll have to model for it. So you're going to need a system to manage all that data, and even other data that might be just engineering related, spreadsheets that calculate loads, a number of things. So this is the best place to put it. You want to put it in a central repository that recognizes the information in there, lets you leverage it, and then lets you control it through life cycles and categorization of the files, and can even trigger other things to happen, like PDF generation. So it's secure. You're putting all your eggs in this one basket. You can have a good backed up place to do this, but so also secure in the sense that if you want to, you can lock things down so that they only get edited on a as needed basis with some checks in place, some checks and balances, and recognition of revisions. Okay, so even non-Autodesk products are able to use data management. And last but not least, if you want to send the information and leverage it downstream in other tools, MES, ERP systems, right? Quickly export the BOM from this database into another. You can. This will begin to give you some ways to do that. So keep that in mind. You're going to want to also do that. If you do it in the beginning, it's going to be much better. If you do it after the fact, you're going to have to go through the process of importing your data that might lie on a server and getting it into a data management tool. Okay, so in closing, I just want to state a couple things. I want to talk a little bit about developing those workflows. How are you going to access this data? Are you going to go through this process of cutting and pasting or importing data? Are you going to create it from scratch, or maybe identify what stuff can be done that way? Right? Identify purchase components versus non-purchase components, and know the process that you're going to go through to release it, to identify it. That means you're going to identify the right properties to embed in these files. Know how you're going to edit it in the future. Again, that determines, what information you're going to put in the file as far as parameters. Are you going to edit the length? If so, you're going to need a length parameter. And also, get yourself familiarized with your team and get them familiarized with the process that you're developing as well. Okay. Last but not least, right? You saw the workflows, but in terms of the links, there should be, 3 separate links we made available to you. The unlisted Jumpstart videos. We also have a, preset search there for Content Center videos, not just one, but, anything we've done on Content Center, as well as 2D to 3D. The subject, has come up a number of times. There are different methods to go about it, not just one, right? So you should have access to lots of different workflows just through those videos and get a good idea as to how you're going to approach things. Okay. So with that said, I'm just going to go ahead and open it up for some Q&A. And Christina, I'll just check with you to see, hey, is there any questions out there that people are asking that we need to answer?
We don't have any questions on YouTube, and I'm not seeing any come in on the chat just yet.
Okay.
But once again, as a reminder, all of those links that Hav talked about are in this chat. So especially those Inventor Jumpstart ones, be sure to click on those before the video ends because those aren't found on YouTube. And be sure to check out our upcoming sessions. We have some listed out until mid-October. Thank you so much, Carl, for joining. Thanks for the shout out.
All right. Thanks, everybody.
Okay, everybody, we'll see you at next week's session. Have a great week.